Okay. Hello everyone, my name is Alaa AbuHelwa, and today I'm going to show you lab 2 of motion of falling object. Table of contents of today are purpose model result, introduction, analysis of box motion, construction of computational model, and observed versus predicted graph. Then we're going to ask a few questions. The purpose of this experiment is to compare and analyze the effects of gravity and drag force on a falling object. The model will show the impact of a drag force in the direction that is opposite to the object's motion. The magnitude of force will be proportional to the object's speed squared. These will be shown in the graphs found from tracker program and the flow script code. And then the results will fall at the same speed no matter what mass there is, since there is no drag force. And then the drag force is affected by surface area and weight. Some principles that are needed are Newton's second law that states the acceleration of an object is directly proportional to the net force acting upon it. And then for a falling object, only forces acting on the object are gravity and drag. However, there is a net force, so there is a change in velocity. So the forces are not equal and opposite. Here are some of the formulas that we're using: velocity update, position update, for due to gravity and drag force equation. And then some key concepts for gravitational and drag force are where m is the mass of the object and g is the acceleration due to gravity. And then the force is pointing in the negative y direction. And then using this formula here, we can find the gravity of the Earth using the mass of the Earth and the constants and everything. And then for drag force points in the opposite direction of the force due to gravity. And this experiment, the drag force is upward. The system would be the block that I used, and then the surroundings are everything else. And this is a free body diagram explaining these concepts. Okay, so key assumptions are drag force always proportional to the speed, gravity constant is 9.8, motion is only in the y-axis, and then we're going to have two computational models, one with drag force and without drag force. Some initial conditions would be velocity equals 0 and position equal 1.5, but it starts at 0. Okay, so in this video, I'm dropping the object with the initial position 0 and resulting value is 0 as well. And as it drops, you can see that the tracker is tracking the motion and recording the data. Here are some of the formulas that we use in the code to replace and to input into the code. This is the code without the competition model without drag force. We changed the mass m for both models, which equals to 0.35 kilograms. And we placed the formulas here where were needed as shown before. This is with drag force. And the only difference with this is it's very similar, but then we had a b constant because due to the drag force formula. And then we added the other formulas as well. This is the observed versus predicted graph. And as seen in the graph, once drag force is applied, actual position is a lot closer to the predicted position. Some source of errors would be block moved in the direction of x direction due to the AC, or a blur on timestamps, or external forces or time intervals. Finally, what does it mean? We're going to ask two questions. Which model predicted a terminal velocity, and what if the object was thrown horizontally downwards? Terminal velocity happens when the force of a drag pointing up has exactly balanced the force of gravity pointing down. This means that the net force will be 0 since the vertical force upward by resistance and drag will be balancing the downward force of gravity. The object will no longer be accelerating. None of the graphs depicted have a stable velocity, so this means there is an acceleration. However, toward the end of the graph, velocity begins to stabilize and is increasing less and less exponentially. If the line representing drag force was allowed to continue, it would reach terminal velocity. Terminal velocity would be the same regardless if the object was dropped from an initial speed. And this is because terminal velocity is determined solely by the balance between gravitation force and drag force, regardless of the object's initial conditions. So yeah, it would be similar in both conditions. And thank you so much for watching this video. Thank you.